Before a single pixel dances, before your mega tree spins, and before xLights sends out even one packet of data, your show needs something way more important than lights, a network that actually makes sense. And here's the secret. If you can understand a neighborhood, a mailbox, and a sticky note on a kid's forehead, you can understand everything you need to know about IP addresses, gateways, DNS, and subnet masks for your Falcon Player, your controllers, and your show computer. So today, we're building your entire light show network using the simplest analogies ever, so you finally get it once and for all. Let's start at the very beginning. Where does every device in your show live? So in a simple explanation, what we're trying to do is get our Raspberry Pi or our xLights or xScheduler to talk to our controller, and then our controller talks to our lights. Real simple, real easy. So a lot of people have this network set up here. You've got your switch and you've got everything plugged in almost like a giant wagon wheel, and that's everything connected together, but is it talking to each other? Or you have this other setup where everything is wireless connected to your access point, which is connected to your router, which is connected to the internet. So there's our two setups that we're going to be looking at. Static IP address is a fixed, unchanging internet address assigned to a device on a network. So if you think of static like static on a TV, it doesn't change. It's always fuzzy, it always looks the same, and so it's very static, it doesn't move, it doesn't change. That is the definition of a static IP address. Now, a dynamic IP address is automatically assigned to a device on a network by the Dynamic Host Configuration Protocol. We've all heard of it as the DHCP. So the DHCP, the dynamic IP, is basically like a piece of music with its dynamics. It's loud, it's soft, it goes fast, it goes slow. It's always changing, so it's never the same. So if you think of dynamic, it's like a dynamics in music. So it's always changing. So what is an IP address? An IP address, which stands for Internet Protocol Address, is a unique numerical label assigned to every device connected to the internet, essentially acting as its online address that allows other devices to send and receive data to it across the network. Everything needs a place to live in our town. Our controllers, our xLights, our computer, our X or WLED controllers, everything needs a place to live. So we're gonna build our little town right now. So let's talk about our DHCP. The DHCP is basically like a management company of our town. All right, so the management company has all these rental homes that they're renting to people that come in and want to hang out and want to live in our town. So first, let's take Johnny here. Johnny comes into town and he's looking to rent a house. He wants to hang out for a couple days. And so Johnny gets there and our rental company is now looking at all the homes that they can rent little Johnny. So Johnny says, all right, I'll take a house, and our DHCP or our rental company says you can stay in the house 192.168.1.123. So little Johnny gets his stuff, he moves into the rental home of our first home there that's in purple of 192.168.1.123. Well, now Johnny has overstayed his welcome, he's gonna go ahead and leave, and he's no longer gonna be in that rental home anymore. So he packs his stuff up and he gets out. So this is basically like you turning on your controller, it gets an address, and then you turn off your controller. Okay, so now Johnny is left. Well, here comes Frankie. Uncle Frankie, he's looking for a house to live in. So he comes by the management office and says, I need a house to live in, and they go, great. Well, Johnny does not stay in that house anymore, so we're going to rent you Johnny's house, which is 192.168.123. So they look at the strip of rental homes here. He moves into the first house where Johnny used to live. So he's living in there, and now Johnny is coming back and he needs his house. Well, the problem is because Johnny was renting the house, he now has to rent a different house with a different number. So 192.168.1.123 is no longer available because Frankie lives in that house now. So now you've flipped on your controller and it can no longer be assigned to that IP address because you have it on DHCP. The management company says you can't live there anymore, and it assigns it to another IP address. And so therefore now little Johnny now moves into 192.168.1.124. So now he is neighbors with Frankie. So if your xLights or your Falcon controller is looking for Johnny that's living in 123, he's not there because now he lives in 124. This is why having a static IP is so important. So now let's look at our static IP. The static IP is like having a realtor, okay? So here's sad Linda. I don't know why she's sad, but she looks sad. And Linda's looking for a place to live. So Linda comes to the realtor and says, hey, I see this house that's for sale. I would like to purchase this house. So the realtor says, great. The address of this house is 192.168.1.125. Linda goes, great, I'll buy it. And she sells the house to Linda, and now Linda owns the house. Now, if we go to our neighborhood, you can see that Linda owns that house, 192.168.1.125. Now, if Linda leaves and comes back or goes wherever, or she moves out for a little bit, that house is still hers, and no matter what, they will not give up that address to someone else. That is a static address. So it will always search for that address. So if your xLights or your Falcon Player is looking for that address, it will always search for that address. Now that Linda lives in this house, we come across a few things that say on our Falcon Player that we cannot ping a certain address, or it's asking you to ping another address. So basically, to ping an address means you're going to go up and you're going to knock on Linda's door and see if she is home. If she's not home, we're going to come back and say, hey, Linda's not at home. We can't ping her. We can't get a hold of her. So the address is still there, but nobody is home. Linda needs to be in her house to actually make these things work. If she's home, then we can ping her, we can knock on her door, and she is there. So sometimes when we get that error, say we cannot ping a certain IP address, that's what that means. It's not there. The address is still available. It's still dedicated to Linda, but she's not home to actually answer the door. All right, so let's get into the IP address. Everybody has these numbers in their basic network, and so this is how I understand it, and this is how you're going to understand it, all right? So typically we have a 192.168.1.something in our addresses here. So we're going to go with the address 192.168.1.121. So the first number, we're going to pretend like that's the state that we live in. The 192 is the state. And we welcome ourselves to the great state of 192. Now the second number, the 168, that is the city that that piece of gear lives in, or that we live in. So we have our state, we have our city, which is 168. So we welcome ourselves to the great city of 168. Our third number, that is the street that we live on. That is the street that the piece of gear lives on. This one happens to be dot 1. So now we welcome ourselves to the great street of dot 1. So we've got our state, our city, and our street. And the final number, that is our house number, which is 121. So that is where our controller, or where we live, is house number 121. And in this figure, you can see that there's other houses that live around us. So once again, we have the Linda, and we have Johnny, and we have Frankie that all live in these houses. So these are our different houses that they live in. So now let's look at our subnet mask. Okay, the definition of a subnet mask is as follows. A subnet mask tells devices which IP addresses belong to their own local network and which ones are outside of it, so they know when to talk directly and when to send traffic to the router. All right, so let's look at here. Here we have our mailman. And so the mailman is getting ready to code to deliver letters, but when it gets its mail truck full of letters, it's not going to drive all over the world looking for your address. You've got to narrow it down somehow to get the mailman to your street. So once again, our subnet mask is the first number, the 255. That's going to tell the mailman you're going to look in this specific state of the first octet or the first number there, the 255. The second number tells that you're going to look in that specific city of that IP address. So it's 255. And the very last number, or the third number is going to be the street, 255. So now our mailman knows to look at the state, the city, and the street. And now it looks at 0, which tells it it's going to look at all 255 addresses on that street to come find us. So much easier for the mailman to come and deliver these letters. So what is this static/default gateway? The default gateway is the single IP address on your local network that every device uses as the next hop for any traffic destined outside the local subnet, typically the private IP of your router. Okay, that was a lot of jargon. Let's dive into it. This will be super easy. Okay, your controllers now have houses. But what if they need to leave the neighborhood? What if your Pi needs an update for Falcon Player? Or you need to download xLights effects? They all need a way out. So imagine all the pixel props in your house want to send letters to grandma, but they're little and they don't know how to get outside. So mom says, if you ever need to go anywhere outside this house, put your letter in the red mailbox by the door. That's the only thing that knows how to leave. That red mailbox has one special address, 192.168.1.1. Mom hands every kid a sticky note and says, your way out forever is 192.168.1.1. That sticky note is the static gateway. Static is glued with super glue and never changes. Gateway, the magic exit door, now knows the whole world. So when your controller says, I need an update, it looks at its sticky note and yells, take this to 192.168.1.1. He knows the way out. And boom, your router sends it to the internet. That's all a gateway is. The universal exit door for your entire show network. And that's it. The secret language of your entire light show speaks. Once you understand that every controller has a state, city, street, and house, that your gateway is one magical exit door, that the DNS is the mom with the magic phone book, and your subnet mask decides who's part of the neighborhood, suddenly networking isn't scary. It's just a tiny digital town where all your lights live and you are the mayor. And the best part, now when xLights can't find a controller or Falcon Player isn't responding or something mysteriously doesn't talk to something else, you'll know exactly where to look, exactly what it means, and exactly how to fix it. Because your light show doesn't become magical when the pixels turn on, it becomes magical when everything behind the scenes works perfectly. So now that your network makes sense, go build, go test, go create something amazing. Your pixels are ready to dance, and now your network is too. This is Twinkle Tunes and Lighting, and I'll see you in the next build. Thanks so much for watching. Hit the like, hit the subscribe, and we'll see you in the next one.